This example of a P-chart construction in statistical process control is taken directly out of the Krishnamurthy text on quality engineering, page 254. So if you have that text, you can be reading along there as we go. In this particular example, we've drawn a series of castings, a variable number of them for each of 35 trials as we've gone through, and they've counted how many of those castings are defective as they go through. This is not a measure of how many defects does each casting have, just does the casting have defects or not? Is it defective or not? So this is a situation where we would use a P-chart to plot this data going through. So historically, this is one of the examples in the text that I want you to pay attention to. Historically, we've talked about SPC as though it's being done on paper. The original people who did SPC go back to the 1940s and 50s and 60s. We didn't have PCs and Excel to do all this in yet. We didn't have microcomputers everywhere we turned. So a lot of these things had to be drawn by hand and calculated out very, very differently. So very often, even though the equations for the P-chart will look at the variability of the sample size going through, sometimes, and the authors suggest this in their example, sometimes we just build our charts based on the average sample size going through, largely because it simplifies the conversation. So this mean of 160 or 161 can easily be used to build a chart as we go through. So if I take the equations for the P-chart and I build that out, I'm looking at the average duration as I go through, as I'm working my way through. So this 0.436 P-bar is going to stay the same because it's the average across all the different data sets going through. But then the calculation that I do of this limit is using the average number way over here, the average sample size going through, working its way through. So I'm not actually building the traditional P-chart yet. This particular example is building a case where I have a simplifying assumption. Rather than calculating my limits based on the actual sample size that I'm looking at, I'm basically going to pretend it's a constant sample size, in this case of the 161 average across the case, and build my charts accordingly. So if I start by building my charts that way, I get straight lines for my control limits, and that's the shortcut advantage that people talk in terms of when they talk about simplifying an assumption. If you're doing this on paper and manually doing these calculations, you don't want to be doing a completely different calculation of the limits every time. But that's a shortcut that really is obsolete. We shouldn't think in those terms anymore. You shouldn't be thinking in those terms. You should go ahead and plot the data according to the real formulas going through. So your control limits would actually be based on the size of the sample in terms of its row. You can end up with a different chart doing that, but because you're using Excel, there's no reason to use any of these simplifying assumptions. So here's the difference in the chart. Here's the real P-chart for the variable sample size coming across as we see our way here. Notice the level to which the sample size goes up and down. The very small sample size of 26 in this first case results in very, very wide limits. The larger sample size of 158 or 150 results in very, very narrow control limits. So this one on the right is actually the correct P-chart coming through. The one on the left is the simplified P-chart of not doing that complex calculation every time, but instead just treating the average sample size as sufficient. If you've got very little variability in your sample sizes, there's no harm in doing that. You're going to get the same results as you go through. In fact, we can show that if I were to plot my data differently and look at the difference. So here on 3940, I'm looking at, is the data point in the fixed estimate an outlier? So the red ones are all my outliers here that are outside the control limits. I repeat the process again for the outliers in the variable control chart, and then I compare them to see if I get a different result. And what you'll see here is that of all of these calculations, the only calculation that comes out different in these two methods is the upper control limit violation of the last data point. That is an outlier according to the fixed chart over here. The point's a little high, and over here it's considered not. It's that close as we come through. So the point here is just to take a look and say the two methods give you pretty much the same result as long as the sample sizes don't vary that widely. Now you might have looked at the sample sizes up here in row 2, so well, that's actually quite a variation. Plus and minus 20, 30 on the sample size is fairly significant going through. It turns out, no, it's not. The estimate works out just fine. The need to do the complex calculations isn't as serious as one thought. And that's why 50 years ago, the way we would have taught how to do the P-chart would be to take the average sample size and use it for a straight line fit on the control limits as you go through. Today we don't have to do that. We have spreadsheets building this. If you're going to bother to build the spreadsheet, you might as well build the spreadsheet to be accurate. But again, there may be reasons why you want to back that up. I know my analysis should be based on the graph on the right, but I'm very tempted to say I should just simply use the graph on the left if I'm presenting to management so I don't confuse them with the differences over the sample size. The data is the same as I go through. Notice the data charts are identical in both cases. Just the difference tends to be a very, very slight variation in the limits, such that one data point here out of 70 turned out to be different. So you really have your choice when you do that. But that's your basic P-chart, seeing your way through. You've got the formulas available to you in the text. You can calculate it both ways. But if you're using Excel, I suggest you use the standard equations and build the more complicated chart to really show that you understand it going through.